Let's see how set handles that. Sets usually reserve more space than they require. In this example, we are reserving space for 10 elements. We will try to add 14 first. Set uses a hash function to find an index for the given element. To simplify this, let's assume that a hash function returns the last digit. So we will store it at index 4. Similarly, we can add 27 to index 7 and 33 to index 3. When we try to search for 27, we need to compute the hash again, which will be 7. We will compare the element at index 7 with 27. If they match, then the value is in the set. We will search for 55 next. We will compare the element at index 5 with 55. If the position is empty, then the value is not in the set. Let's try to add 44. There is already an element present at index 4. This phenomena is called collision. There are many ways to handle it. The simplest one is to put the value in the next available slot. When we search for 44, it will keep comparing elements starting from index 4. If found, then it's in the set. Searching 55 will start comparing elements from index 5. If it finds an empty slot, then it's not in the set. The previous example was given just to understand how sets work. Python uses more sophisticated hash functions and collision handling algorithms for better efficiency. We can see what hashing does for a given value by using the built-in hash function. For integers, it usually returns the same value. But for any other type of value, it will also return an integer for an easy mapping to index. However, not every data type is hashable. This video is part of a Python tutorial series. Click here to watch the full video and click here to watch the full course. Thanks for watching. See you next time.